In this video we're going to start doing some quality control checks on our data. So if you have phoned your project, you should have several ground control points on hard surfaces or possibly some painted targets for you to be able to check the fidelity of your data. In our case, we've got for this little sample data set 3 storm drainage inlets that we should be able to see with our data and use it from there. There should be one somewhere in here. There's one, and a couple in a couple other places. So let's bring those GCPs or ground control points in to the software. We're going to go to File, and we're going to import an ASCII XYZ. We're going to create a shapefile. And now what do we want to add? We're going to add the data. So let's navigate to right here, and I have this as a CSV. And now this should seem familiar to anyone who's ever imported any data, a CSV file into most anything. So we're going to step through telling it what each one of these files columns are. Where do I want to write this shapefile? So we're going to put it right here. I'm going to put it under my project for this one that we're in, and we're going to make a new folder and call it GCP and put it right there. And hit next. This is a delimited file. Next. It is comma delimited. Next. And now I tell it what each column is. My first one is the ID. Then I have northing, easting, elevation, and description is what my file set is set up as. And then I'm going to hit finish. And it very quickly created a GCP layer. Turn off these and you can see those 3 dots. I want to make them pop and be a bit more obnoxious. So I'm going to double click on this purple icon here, or pink, whatever color it is. I'm going to make them an 8, and I'm going to make them yellow. And hit OK. So now I can see them. And in this case, I don't have a lot just because this is for tutorial and it's a tiny area. But I can quickly see that this GCP is outside of where I have good data. But I don't know which point that is. So I'm going to come over here and right click on this, and I'm going to show the labels. That's point 1007, and I'll make note of that. Now that I have them imported and I've noted any of them that are outside of my area, and there's a whole bunch of additional steps you can do with GCPs, but I'm just going to give you the brief rundown. We're going to come back over here to our toolbars, and now we have a shapefile in here. I now need to tell it it's a control point. So on this toolbar, which is the LP-360 control points toolbar, aptly named, I'm going to tell it what my control points are, which is this shapefile we just made using the shape. And now I can click this little calculator table looking thing to open up the dialog box. With this in here, remember that one of my points was bad. So, and I told you to remember the point number, and for some reason it's not showing up. So we're going to just double click these. And if you notice, if I double click them, it's hard to see with this dialog box so big. Let me see if I can shrink it down for the video. If you double click them, they will zoom to the ones in question, or you can turn them on and off in this case. So our bad one is 0.0 for some reason, so I'm going to uncheck it. Let's make this bigger so you can see again. We want to check we're doing this to check the accuracy of our data. So let's change it from 10 to IDW, and I want to check all points within, I don't know, let's say one map unit, so in my case feet, of the points, and let's hit calculate DZ so you can see what happens. So it has told you what the point is, what the surface elevation is, and the delta for each one of them that you have checked. You could come in here and change some things and look at it if you wanted to, but here is the nuts and bolts. Now remember, we're checking the vertical accuracy. We're not going to mess with horizontal right now. So I have a mean error of negative 3.25 with an RMSE of 0.34. This is basically, these two are generally very close to each other. This is just getting rid of a sign. And your SDOM, and I won't get into too much statistical information, but what matters here is that the SDOM and the mean error and the RMSE. If the SDOM and the mean error are very different from each other, that is an indication that your data has a bias, which means you can correct the elevation of the data by that bias. So 0.086 and 0.34, very much 4 to 5 times greater. So I'm going to say I do have a bias. So I'm going to write that mean error down. So negative 0.325. And now that I have identified a bias, we're going to correct that data, which is our opportunity to start looking at tasks. So things that you're going to do with your point cloud are typically considered point cloud tasks. So down here at the bottom of your table of contents, you can click point cloud tasks. And on the processing task, we're going to make a new one. We're going to click this button here to open our Cloud Task Manager, and we'll hit Add. We're going to give it a name, whatever you want to name it. I'm going to put tutorial, but I would call it something along the lines of dBias Z. Under the task type, you want to, near the top, you're going to choose this Affine Transform LES and hit OK and hit OK. If it didn't automatically put your new one here in this pull down, you can click it and select it. We're going to leave these alone. We're going to go to rotate, scale, and translate. In our case, we're going to translate, and this is how you could rotate and move it to a local coordinate system as well, but in our case we're just debiasing the Z. And right here I'm going to put that mean error that I had, so negative 0.325. I'm going to scroll down, and it wants an output location, so let's give it an output folder. Does it pop up the IO manager? We're going to click right here next to the folder. You can click this button to navigate, or you can click this right here, which is a shortcut. Let's say wherever my project is, I'm going to put a backslash and give a new folder name. So let's call it LES dBias Z, and I'm going to hit close and hit apply. And that is, when you hit apply, it did not run the tool. It just applied your settings. In order to run the tool with it open, you will come over here to this, and if you're running it for the entire point cloud, this checkerboard here executes it for the whole project. So let's run it. It took 2 whole seconds. Now when I go back to here, I now have another layer, LES layer 1. So I'm going to turn off my other one, do a little bit of layer management, move it back down near the bottom, and for my sanity I'm going to rename this LES aligned debiased, so I know what it is. And now that I have multiple LESs, you'll see that I have multiple here. So now we've got a data that has been geocoded, hooked to the trajectory, and then debiased all in here.